Hello everyone. We are here to present our wireless project presentation, and our topic is how to manage Docker deployment on AWS. My name is Priyanka Dayal and my group member YK. We will present this presentation. Let me allow to start the presentation. Firstly, I will discuss the problem statement. Basically, when developer develops any application in his or her system, the laptop, and sometimes when they provide it to the testing or the production team, it doesn't work for them. And the reason behind that is the differences in the computing environment. For example, maybe the system where developer develop that application where the software is upgraded, and for that test or the production team, the software having the old version, so it will create the problem. And the other reason is microservices split that application into number of services, and each service run into its own processes, so it's require different virtual machines, and each virtual machine needs the resources of the host machine, so it basically leads to the wastage of the resources like RAM or the disk space. So to overcome all these problems, we can use Docker. And what Docker benefit us if we want to run several microservices in the same virtual machine, then by using Docker container, it is easy to run those microservices. The other thing is Docker provides us the consistent computing environment throughout the software development cycle. And the next is when we use Docker, it provides us the easy environment to deploy and scale applications into any other environment. So what is basically Docker? Docker is open source platform that is used to build, test, and deploy applications in containers, and that applications can efficiently work in different environments. And these Docker containers are lightweight when we compare with the virtual machines, because it doesn't require the pre-allocation of the memory. This is a Docker architecture. It basically follows the client-server architecture. Here, Docker client, Docker host, and Docker registry. Docker client talks to the Docker daemon, and Docker daemon basically creates and manages the Docker images, and this Docker daemon build, pull, and run the commands that is used by the Docker client. And this Docker registry is basically a storage unit. And for example, Docker Hub is a local registry for storing Docker images. Now, these are the Docker architecture components, like Docker client talks to Docker daemon, and the all responsibilities for building, running, and distributing Docker containers. And Docker client and Docker daemon communicate with each other using REST API, and Docker registry stores the Docker images. Now, what is Docker image? Docker image basically built by Docker user, and these are the set of instructions and read-only templates that are used to create containers. And Docker images are stored in Docker Hub, and that is also known as the local registry. And Docker containers are basically isolated application platform that contains everything that is required to run the application. And Docker containers basically provide the runnable instance of an image, and it is easy to stop, delete, or run the Docker container. And now Amazon Web Services. Amazon Web Services provides several cloud-based services like storage, computing, security, management tools, and these help organizations to move faster, provides low cost solution and easy to scale. And Amazon Container Services having two orchestration tool, ECS and EKS, and each orchestration tool having two launch type, EC2 and Forget. And here in this project we are using Amazon ECS, Elastic Container Service, which is basically used to provide high performance container orchestration service, and it is used to deploy, scale and run containerized applications on AWS. Here this flow diagram, container image basically a set of instructions that are used to create containers and stored in container registry. That container registry may be Amazon ECR or Docker Hub and accessed by the Amazon ECS. And here VPC, this is a virtual private cloud. This is used for network isolation or the security purposes. Now, Docker on AWS implementation. Basically, Dockers are considered a great solution for CI/CD, continuous integration and the continuous delivery. For example, a developer has developed some application and shared with the team members using Docker container. So whenever that developer make any changes in the code, then it is easy for the others to deploy that code on the server. And so it provides a highly reliable and cost-effective way to build, ship and run distributed applications at any scale, at any environment. So this is the project design. Docker file is developed by the developer and pushed to the ECR, that is basically a registry, and these Docker images are pulling for creating cluster, task definition and the different services, and after that that testing that can be assessed by the users. So now over to my group member YK. Thank you.
Thank you, Priyanka, for introducing the project design. So after creating the clusters and EC2 instance, what we like to do is to push our code in a repository and have it deployed automatically on the ECS. So this procedure is called a CI/CD deployment, which stands for continuous integration and continuous delivery. Developer will first push the code to the code repository, and in our project, we use the code commit Amazon service. It's used to store the code in a private repository. We use the Git interface to push the code, and after that, a testing and building server will check the code as soon as it is pushed, and build the codes and run the commands like the docker push. So in our project, we use the code build, which is also the Amazon service. For code pipeline, it will orchestrate all the CI/CD steps. It detects any changes in the code repository. It will pass the code to the code build automatically. So in the code build, the developers can get the feedback about the test and check whether the code is passed or failed, whether it can deploy. So if it is passed, the code didn't have any bugs, it will push the image to the ECR repository using with a new tag. So this service can help developers to find bugs earlier and fix the bug and fasten the delivery procedures as the code is tested before deployed. So the above code commit and code build is the continuous integration part of CI/CD. So next, after code build has passed the image to code deployed, we will move on to the continuous delivery part. It is used to ensure that the software can be released reliably whenever needed. It would automatically deploy the new version of your application. So we use code deployed in our projects to automatically deploy the code to the ECS, and it will create new task definitions and update the service at the same time. So these are all the AWS service we used in our project. Like we mentioned in the project design and architecture part, it includes like EC2, ECS, and code pipeline, etc. So next, I'm going to explain the installation path step by step and show you the demonstration. And the The first thing we do is install all the prerequisites like Docker and AWS console. So we create the AWS account and set up the management consoles and do all the stuff. And after that, we will create a Docker file. So the Docker file is important because it's used to push the Docker image by your specifies. So I can show you my Docker file here. So it includes all the steps necessary to build the image. You can see here we set the necessary environment variables and move to the working directory and copy the codes and build the application. So this files will automatically build and run all the command inside this Docker file to build the Docker image to the ECR repository. After that, we will create a repository in Amazon ECR. In this interface, we can see how the repository is built. You can see here is the repository I use in this project, and it includes information like the URL to push the image. And after pushing the image, you can see the image tag with the latest. So next we'll move on to create the clusters along with the task definitions and service inside to pull the image from the ECR repository. So in this website we can see the clusters here, and this is the cluster I built along with the task and service. In the task we can see the informations of the containers like the IP address I used, and you can see the image here is the same URL within this repository. So after we create the cluster, the new task definitions, and the new service, we can go check the EC2 instance page, and we can see the EC2 container and the EC2 instance is automatically generated, and we can check on the ID and we can check on the details of this container. We can see the public IP address, the instance name, the instance state should be running, and all the stuff here. And one more step to make this IP address accessible is to configure the security groups and to allow all the traffic go in this website. So I've configured all the IPv4 and v6 TCP can go into this application website. So after adding the rules to allow all TCP traffic, we can now browse the public IP with this website. So this is the application we built in this project. So the above step is show how we build these containers and running the application with the public IP address. So next I will talk about how to implement the AWS code pipeline. So code pipeline is the automated CI/CD process orchestrator, and it is used to deploy the new version of the application to the ECS cluster automatically. So this is the Amazon code pipeline interface, and you can see here for the source we use the Amazon code commit to push the repository to the code commit, and then we go into the build stage which we use the code build for building our applications and check if there is any bugs. And for the deploy stage, we use code deploy to deploy the application to the Amazon ECS service. So when we check the code commit interface, we can check the repository that we have built. And when you click on the repository, it shows all the code for these applications, and you can see the Docker file, the application we built, and also we have to create this build spec YAML file, and it is, contains all the build commands using for this building this containers and application. And inside this file, you can see different stages. We tell the containers what to do and what to build. And in the code build service, we can check on the project we built, and inside this service, we can check whether the status is succeed or not. In our project, the status is succeed. Encounter some errors, you will face the status is failed, and you can check on the logs and build details for find out the bugs and fix the bugs. So for the final step of this project is to build the code pipeline. So for the deploy stage, we are going to deploy the whole application in the ECS container, and if the code pipeline detect any changes in the source stage, which means it's in the repository in the code commit, it will trigger the build code build, and then it will deploy in the ECS container. So I will demonstrate now. So I'm going to change something in the repository for this applications and show you how it will automatically change the application. Now I have the code for this application, simple HTTP GO, and inside it I type local IP 123, and this is what I'm getting in my web page. So for the local IP, it shows 123, and now I'm going to change the message to local IP instead, and I'm going to click the demo. I'm going to type the offer name to demo and the email address. So I will click on commit changes. So now I can see my pipeline is committing the change. The code pipeline detect the change in the code commit, and it shows that it is in progress. And now it's go on to the build stage, which used to check if the code is succeed to build. So if this build stage is succeed, we can see a new image is pushed to the ECR. So now the build stage is also succeed, and it will go into the deploy stage, and it is going to deploy it automatically. Now I'm going to check whether it is succeed to build or not. So I'm going to the task, and I'm going to check this public IP. So you can see here the local IP is showing without the numbers 123. So in this event page of the services, we can also check the event that happened in the container. So just now, what happened is I commit a change in the code pipeline. So it start a new task with this ID, and the service will automatically stop the old task and running the new one instead. So it also shows that the service deployment complete, which means the it is deployed to our container. To conclude, we have introduced Docker architecture in this project and show how to manage the Docker deployment on AWS service, and using the AWS code pipeline service, which helps to automate the step required to release the process for developers to release new changes to the applications easily and faster. So besides this, Docker deployment on AWS is highly reliable, cost-effective, and also easy to scale. So this is the end of our presentation.